Okay, hello guys. Today we are starting with 111, section 111, the real number system. We're going to be classifying the numbers today. All right, so to begin with, the real numbers, that's the set of numbers, and I'm using the hashtag symbol to be shorthand here, which why it's not focusing. Let's see. The set of real numbers which contains all rational and irrational numbers. All right, so let's talk about what's the difference between these two. Okay, so irrational are decimals that never terminate or end and have no repetition. So decimals that never end and never repeat. Examples are the square root of 3, pi, the square root of 5, the square root of 41. Because if I were to punch these into the calculator, these would all of these square roots would end up with long decimals that never repeat and never end. The calculator may stop it, but it's because the calculator program only goes out to so many decimal places. Rational numbers. Keyword to remember here, okay, is the word ratio inside of rational. A ratio can be written as a fraction. Can be written as a fraction. Okay, so all fractions. So a rational number is all fractions, or numbers that can be written as a fraction. For instance, A over B. That's the form that it can be written in, where A and B are integers. Or it is a decimal that terminates or ends or have a repetition. So it's a decimal that ends or repeats. Because if it repeats, it can be written as a fraction. So examples for these are 5/7, 3, -1, 20 over 5, because that equals 4. You always simplify to classify. Simplify to classify. Okay, next example is the square root of 16, because that equals 4. So again, here I'm going to put this in the purple because I should have changed colors there. Another example is 0. And then the last example is 2/3, because remember, 2/3 is the same as 0.6 repeating, which is also 6/9. All right, here we go. So we're going to be classifying, okay? Integers, so we can remember. So integers, examples of that are ... -3, comma, -2, comma, -1, 0, comma, 1, comma, 2, comma, 3, comma, ... Okay, I think of this as positive and negative whole values and 0. Whole numbers, that's going to be 0, 1, comma 2, comma 3, comma dot, dot, dot. And this is 0 and positive whole values. Natural numbers, I also call these counting numbers. And if I go to count something, I don't start with 0. I start with 1. So this is 1, comma 2, comma 3, comma 4, comma dot, dot, dot. So this is positive whole values, but the big thing here, no 0. There is no 0 in the natural numbers. All right. So now, if we're looking at a Venn diagram, okay, big picture, it is all real numbers, okay? This section that's separated, this is irrational numbers, and then we're going to start from the inside out, okay? From the smallest section, this is the smallest section, this is natural numbers. Then we have the natural numbers are inside whole numbers. Natural and whole numbers are inside integer numbers, and natural, whole, integers are all inside rational numbers. Okay, now let's work through a couple of problems as we go through. So when we're looking in the back of here, we're going to name all sets to which each number belongs. So I'm going to look at the number negative 47. If I need to, I'm going to flip it back over and look at my Venn diagram or my notes. Negative 47, that's a negative number. Okay, I can write this as a fraction. It's a negative whole value, so this is going to be real, rational, integer. And notice you can shorthand them. Okay, 2 3/8, well, I can't simplify this to a whole number, so I know it's not going to be an integer, whole, or natural. It's written as a fraction, so I know it is going to be rational. And for all of our purposes, guys, every number is going to be real because these are all real or rational. I'm sorry, rational or irrational. Okay, negative 9, the absolute value of negative 9. That means I need to simplify, which is going to give me a positive 9. So therefore, since it's a positive 9, that means it's going to be natural, whole, integer, rational, and real. And you have to make sure that you list all of them. Okay, square root of 23. 23 is not a perfect square, so this is not going to end up being a whole number, okay? So therefore, since this is not perfect square, this is going to be irrational and real. Okay, so next set. This is 1.565. It ends. That means that I can change this to 1 and 5,625 over, this is tenths, hundredths, thousandths, 10,000ths. I can write this as a fraction. So that means this is a rational real. I can also determine it because it is an ending decimal. 0, well, we know 0, if it's 0, it's not natural. So this is whole, integer, rational, real. Square root of 64, but it's a negative on the outside. That means it's kind of like negative 1 times the square root of 64, which means I'm going to end up with negative 1 times 8, which gives me negative 8. Since it's a negative 8, then it's not going to be whole and it's not going to be natural. So it's integer, rational, real. This right here, this can throw us a little curveball, but it's repeating. That means that this is going to be negative 123 over 999. I can write it as a fraction. That means this is rational. It's a fraction, not a whole value, so therefore it is only rational and real. Negative 24 over 6. That simplifies to negative 4, which it's negative, so therefore it's only going to be integer and rational and real. This number 10, we're skipping. Skip this one. Okay, what I want you to do right now, okay, is you're going to place the letter of the values to the left in the smallest set, okay? That means the most inside. Only write letter in one spot. All right, what I want you to do is you're going to fill this out and then you're going to check with me. So you're going to check with Mrs. Wilson, check with Mrs. Wilson. Do not look at answer key. Do not look at the answer key first. Check with me before you look at the answer key. Do not look at the answer key. Check with Mrs. Wilson before starting the classwork. Have a great day.